Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. So welcome to my video. So basically this is a lecture video for subject Electrical Circuits 1, code BEV 10303, and in this video we are going to discuss in details on the topics for chapter 2, which is basic laws that govern the electric circuits. Okay, so let's go to the next slide where we are going to see the list of topics that we are going to cover in chapter 2. So the first fundamental law that we are going to have a look is the Ohm's Law, all right? And then after that, we are going to see how to define the branch, loops, and nodes. And then after that, we are going to see the second law, which is the Kirchhoff voltage law and Kirchhoff current law. Okay, and then after that we are going to see the difference between series resistor circuit and parallel resistor circuit, as well as on how to apply the voltage division rule and the current division rule. Okay, so the last part we are going to see on how to transform from the network from Y network into delta network, and how to transform the delta network into the Y network. Okay, but basically in this video we are going to cover on the first subtopic only, which is Ohm's law, and then for the rest we will cover in the next following video. All right, okay, so now we go to the first fundamental law, which is Ohm's law. Okay, all right, so before we go to the Ohm's law, the first thing that we need to understand is the concept of resistance. Okay, so because as you might know, Ohm's law is given by V is equal to IR. So in previous chapter 1, we had learned on the topics of what is the definition for voltage and what is the definition of current, right? So now we are going to see what is the concept of R, which is resistance. Okay, so resistance is actually a ability to resist the current. So in meaning that it is ability to resist the flow of the electric charge. Okay, because you know when the electric charge flow, it will cause the current to flow, right? And then okay, so let's say you are given this kind of a material. Okay, so this material is actually act as a resistor, okay, because it has a ability to resist the current. And the circuit symbol for resistor can be represented by this figure, where R represents the resistance of the resistor. So I here is a current flow from this point to this point, and then V is a polarity voltage across the resistor. Okay, and then basically there is several factors that will influence the value of the R. Okay, so the first factor is the cross-sectional area, which is we define as A, and then the other factor is the length of the material. And then the third factor is the resistivity of the material itself. Okay, where we symbol it as a rho, right? So basically, R is equal to rho multiplied with length over the A. Okay, where rho is known as the resistivity of the material, which measure in the units of ohm meter. All right. Okay, next, for the resistivity of the material, basically the resistance can be divided into three different categories, which is conductor, insulator, or semiconductor, right? So what does it mean by the conductor? So conductor is actually a material that always conduct current. Okay, so for example, iron, copper, and aluminium. So in the other word, conductor is a material that has a low resistivity value. Okay, so for the second category, which is insulator, is a material which do not conduct electricity to pass through them. So the example for the insulator is a plastic material, wood, and paper. In this case, the insulator we consider as a high resistivity. Okay, and then for the third category, which is semiconductor, so for semiconductor is actually a material that half conducting device. So it means that it behaves as a conductor in the room temperature, and it behaves as insulator in the lower temperature. Okay, so the semiconductor also known as a partial conductor of electricity, meaning that their conductivity lies between conductor and the insulator. Okay, because it is half-half. Okay, so example for the semiconductor is a silicon and germanium. All right. So now in this slide, the table represents the value of the resistivity for some of the common materials, and the table also show which materials are used for conductor, which material that are used for semiconductor and for insulator. Okay, so basically from here you can see that silver, copper, aluminum and gold is considered for use for conductor, and then for carbon, germanium and silicon we consider it used for the semiconductor. Okay, so you can see that the value of the resistivity lies between the conductor and the insulator. All right, and for the paper, mica, glass and Teflon, so these four material we consider used as an insulator. All right. Okay, so for the resistor is actually a circuit element used to model the current resisting behavior. Okay, so basically the resistor is made from the metallic alloy and carbon compound. So this figure represent the different type of resistor that are available on markets. Okay, so as you might see that the resistor can be divided into two different main category, which is the first one is the linear resistor, and the second one is the non-linear resistor. So for the linear resistor, it's actually a resistor that obey the Ohm's law, and for the non-linear resistor, it's a type of resistor that does not obey the Ohm's law, right? Okay, so next for the symbol for the circuit. Okay, so the resistor can be represented by this symbol. And it's actually from here you can see that the linear resistor can be divided to two different types, which is fixed resistor and variable resistor. So this symbol actually represents the fixed resistor, and this symbol is actually represent the variable resistor, right? Okay. Okay, so for the possible values of R, so R can be actually lies between the value of 0 until infinite. Okay, so let's have a look on the minimum value of R. Okay, so R is actually can be equal to 0. So in this condition, we consider it as a short circuit. Okay, so if you have a short circuit, we consider R is equal to 0. So when R is 0, so voltage also is 0. Okay, so meaning that the current could be anything. It can be maximum or it can be infinite, right? So in practical, short circuit is represent the perfect conductor, which is the resistance is approaching 0 value. Okay, so next for the next maximum value, which is R can be infinite. So when R is infinite, we consider it as an open circuit. Okay, so when you have open circuit condition, meaning that no current can be flow here. So when R is infinite, so I is equal to 0. So when I is 0, so voltage could be anything. Okay? So voltage cannot be equal to 0. So in this case, in practical, when you have an open circuit condition, so the circuit element is considered is with resistance that approaching infinite, right? Okay. Okay, next we go to the definition of conductance. Okay, so actually conductance is a reciprocal of resistance, which is denoted by G. So meaning that 1 over R is equal to conductance equal to G. Okay, so the conductance is actually the ability of an element to conduct the electric circuit, conduct the electric current. Okay, so it's actually a vice versa from resistance, where resistance is ability to resist the electric current, but here the conductance is actually ability of that element to conduct the electric current. Okay, so the unit for conductance is actually mole. Okay, so actually it's a ohm, but we spell it backward, or we can also call it in units of Siemens. Okay, so basically G is equal to 1 over R. Okay, so next we are going to see what does it mean by the Ohm's law. Okay, so first of all, so there is one guy. So this guy is actually a German physicist. Okay, so his name is George Simon Ohm. So he is actually doing an experiment to determine the relationship between current and voltage. So the relationship that he studied is known as the Ohm's law. So it is actually coming from his own name. All right. So basically, when you have a resistor, okay, so you will have a resistor, current flow through the resistor, and then you have a voltage that across the resistor. Okay, so the relationship between V and I is given by this statement. So it states that the voltage across a resistor is directly proportional to the current that flow through the resistor. So in the mathematical expression, V is proportional to the I. Okay, so this relationship is actually can be represented by this graph. Okay, so from here you can see that the V and I is represented by the straight line. Okay, so the straight line have a slope. Slope is equal to R. Okay, so basically from here you can see that the relationship is linear. So that's why only linear resistor obey the Ohm's law, but for the type of non-linear resistor, it does not obey the Ohm's law. Alright. Okay, so in order to apply the Ohm's law, where V is equal to IR, the current and voltage must conform with the passive sign convention. Okay, so remember, for the passive sign convention, it implies that the current flow from higher potential to the lower potential. So when you have this current flow from positive to the negative, so you can use V is equal to IR. Okay, but let's say you have a current flow from the lower potential like this, where you have a current flow from negative to the positive. So the formula that you must use is equal to V is equal to negative IR. Okay. Okay, so now let's do example for calculation. Okay, so the question here, the essential component of a thermistor in an electrical element that convert electrical energy to heat energy. So how much current is drawn by a toaster with resistance of 10 ohm at 110 volt? Okay, so here V is equal to 110, R is equal to 10 ohm. So what is the value of I? Okay, so how to solve this? Okay, so you need to find the value of current. So you know, according to the Ohm's law, V is equal to IR. Okay, so you have V, you have the value of R. So now you want to find the value of I, right? So I is equal to V over R, and then 110 over 10. So lastly, I is equal to 11 ampere. All right. Okay, so next we go to the second example. In the circuit shown below, calculate the current I and then calculate the conductance G and the power P. Okay, so now you have a circuit with supply V is equal to 30 volt and R is equal to 5 kilo ohm. So you need to find the value of I. Okay, so from here, according to the Ohm's law, so V is equal to IR. Okay, so I is equal to V over R. So V in this case is 30 and then R is 5 kilo ohm. So in this case, I is equal to 6 milliampere. Okay, so and then after that, you need to find the value of conductance. So conductance G is equal to 1 over R, right? So 1 over 5K is equal to 0.2 millisiemens. So finally, you need to calculate the value of power. So basically, you can calculate the power using three different methods. So the first method, you can use the formula of P is equal to V multiplied with I. Or maybe you can use P is equal to I squared R, since you have the value of R and I. And then, or you can also use the formula of P is equal to V squared G. Okay, so from here, you see that you have a V is equal to 30 volt, I is equal to 6 milliampere. So you calculate, you can get the value of 180 milliwatt. Okay, so from here, by using this formula, you're getting the same value, 180 milliwatt, or you can just use this formula, you're also getting the same value. All right, so that's all for now. So thank you for watching. Thank you for your time. I'll see you in the next video. Bye.